Hi everyone, welcome to the Earth Science Regions Review podcast series created by Homix Middle School Earth Science Department. Today we're going to focus our attention on the process of deposition. Now in order to understand deposition, you have to have an idea about what weathering and erosion is. Weathering is the breakup of sediments, erosion is the transportation of the sediments, deposition is the dropping off of the sediments. Now these sediments can be sorted or unsorted based upon size, shape, and density of your fragments. Now, depending on what's moving and depositing the sediments, wind, water, gravity, and glaciers are all going to organize their sediments in a different manner. So, when you talk about deposition, you can actually compare the depositional rate versus the depositional time. Something that settles at a fast rate takes less time to sink to the bottom of a river. Something that travels at a slow rate takes a long time to sink to the bottom of a river. So the rate is always going to be indirect. Time will always be direct. Now, glaciers and gravity are going to all have relatively the same characteristics. They're going to give you unsorted sediment that's unlayered, that's going to be unorganized, unless the glacier itself is going to start melting. So the two G's are going to give you unorganized sediments. So you can see here with a landslide and also with a moraine, you have unorganized sediments. Water deposition, on the other hand, is going to be solely organized. It's all based upon the fact that your carrying power and your velocity is going to drop. So when your velocity drops and your carrying power drops, you end up getting deposition. And that's when organization of your sediments will begin. So you can see the horizontal layers of sediment in that sedimentary rock, that's somewhat organized. Now there are some factors that do affect deposition. Okay, the size of the fragment. Your big fragments sink fast and your small fragments sink slow. The shape of them, round sink fast, flat sink slow. And then finally your density. The really big densities are going to sink fast. Your really small densities are going to sink very slowly. Now these sediments are going to be organized two different ways. And one is going to be what we call horizontal sorting. This happens when a river is going to enter an ocean when the velocity and the carrying power dramatically drops. Your largest, your roundest, and your densest will sink out first. Your smallest, your flattest, and your least dense is going to settle out last. So there's a picture of what your horizontal sorting might look like. So you're going to have your boulders, your cobbles, your pebbles, your sand, your silt, and finally your clay. And that's what we call horizontal sorting. Okay, here's Cayuga River flowing into Cayuga Lake. Again, you see the sediment that's being carried into the water. That's going to be somewhat of some horizontal sorting. One of the big features that are going to be found at the mouth of a river is what we call river delta. Okay, and this is going to be sediment that's going to be dropped off. Okay, it's called a delta because it's somewhat in a triangle shaped. So the triangle shaped feature is going to form at the mouth of a river in the horizontal manner. You'll sometimes get these triangle-shaped features on land. Those are what we call alluvial fans. So there's the Nile River Delta, right there. There's the Mississippi Delta, and then finally an alluvial fan. You can also get sediments organized vertically as well. So this is what is going to happen when you get a landslide that happens next to a big body of water. Once that landslide falls into the water, your sediments are going to organize themselves from bottom to top. So your organization is going to be in a vertical manner compared to a horizontal manner. So there's a picture of what a landslide might look like next to a larger body of water, and that sediment might organize themselves a little something like this. Now, sometimes you can get a series of landslides that happen over and over and over again. So you might get a series of vertical sorting stacked on top of each other. That's what we call graded bedding. So you see in that organization is large, medium, small, and geologists can actually tap into the sediment and figure out how many landslides might have occurred in a certain amount of time. Now, wind deposition is very similar to water because they're both fluid. They're going to organize by carrying power, they're going to organize by velocity, and the sediments are going to have an influence on the organization by size, shape, and density. Now, with wind deposition, the big feature here is going to be dune formation. And these are just big piles of sand that can occur not only in beach areas, but also in very dry areas like deserts. You will have a windward side, which is very gentle slope. You have a leeward side, which is very steep. So what happens here, it's almost like a big conveyor belt between the windward side and the leeward side in terms of sand being picked up on the windward and dropped off on the leeward. So dunes tend to migrate, they tend to move. So many cases, especially in beach areas, you might see plants planted on the dunes to keep them from actually moving. Crossbedding can occur as well, most likely with wind, but sometimes can happen with water when the direction of deposition changes. So when the direction of deposition changes, your bedding planes are going to change as well. So what happens is the layers of sediments tend to be altered in terms of their location, in terms of deposition. So you can see there a really nice picture of crossbedding.